All right, 6.5 properties of logarithms. So these things you have no choice but to memorize. Like if you're sitting at home for whatever reason and you're doing this, I need to mention this. You have to memorize. If you're in my room every day, well, you're going to be taking quizzes to help reinforce these things. But if you're at home, you got to memorize these things. I'm not going to give you a daily quiz over that kind of stuff. All right, first off, we have the product property of logarithms. Product property says a logarithm that contains, two or three elements, whatever. I'm going to write A, B, C, but it's a logarithm. Could be an ln, whatever. A logarithm that contains the elements A times B times C can be expanded into three distinct logarithms, one of them that contains A, plus another logarithm that contains B, plus another logarithm that contains C. The quotient property, I usually do four elements in. I kind of leave it like this one, but I put it over log of AB divided by CD. Now, A and B are in the numerator. They're going to stay positive like they were up here. Anything in the denominator is going to become a negative logarithm because we break apart division with subtraction. It's closely related to this rule. These are inverses, so things look different. But if you know that exponential rule, division becomes subtraction and vice versa. So if it's in the denominator, well, we take those away because division becomes subtraction. All right, the power property says a log with an argument and some exponent that for some reason math books call r can be rewritten as r times a log of a. We're expressing that exponent as a factor because it's going to say how many times the logarithm happens. And those are your properties. And the other one, big one, is this one. A logarithm, base b, argument a equal to e, has an equivalent inverse of b to the e equals a. Memorize these things. It is your only chance. Memorize. Memorize those properties. And moving forward, how can you use properties of logarithms to expand each expression? Well, the first thing I see is I see things that are being multiplied together. So I'm thinking about this property right here. A log that contains the elements a and b is a log of a plus a log of b. Wouldn't kill you to write that down a few dozen times. So I can expand this into two distinct logarithms. One of them contains a squared plus the other one that contains b to the seventh. Now the other property that shows up in my mind is this one. A log with an argument and an exponent r is r logs of the argument. So we're going to take these exponents, we're going to move them to the front. So 2 logs of a plus 7 logs of b. Ta-da! All right, this is a try it. You're supposed to try this at home. Use the properties of logarithms to expand each expression. We'll probably just do them in class. But, a little note here. If an argument is in the numerator, remember what that is? It's the top of the fraction. Then the expanded piece is positive. If the argument is in the denominator, the expanded piece is negative. You could even prove, like on this one, you could rewrite a as log base 7 of r cubed t to the fourth v to the negative first. Maybe that would help you understand why it's negative. Because that one is going to get shifted, that negative one is going to get shifted to the front of the bus, and that's going to make it negative. So that's kind of why you get that. Anyways, there's 1, 2, 3 pieces of this logarithm, so I'm going to have 3 log base 7s. One of them's got an r cubed, plus, because this guy is also a numerator, it's got a t to the fourth. This guy is in the denominator, so minus a v. And then I need to take these exponents, and I just need to shift them to the front of the bus. And I'll have 3 log base 7s of an r, plus 4 log base 7s of a t. And then, of course, no change to this guy because the understood exponent was 1, and, those are understood math. B is not a push button in a calculator. The instructions say use the properties to expand each expression. So this guy's in the numerator, gonna stay positive. This guy's in the denominator, gonna become negative. And it's a good question to just prove to you that these properties do work as they're programmed to work. But here's the natural log of 7 225ths. And it should be the same as the natural log of 7. Take away the natural log of 225. And by golly, gee, wow, they are the same exact thing. All right, condensing. So we have multiple logs. We're going to make them one logarithm. And the first thing we have to do is we have to think about this property here because we have to kind of go backwards in how we were doing it. An r log of a is log a to the r. So this 4's got to get moved, that 3's got to get moved. So I'm going to have a log base 4 of m to the 4th plus a log base 4 of n cubed minus log base 4p. And a lot of kids don't like to write this intermediate step. You're just lazy, and it's why it doesn't click. You write down every single blasted step. No math teacher ever said skip to the answer, and no math teacher ever will. Hopefully one day you get to that point, but write the intermediate step. It's kind of how you remember the process of doing things. Now, these two logarithms are positive. They belong in the numerator. This guy is negative. It belongs in the denominator. So we're going to have a single logarithm. Her base is 4. In the numerator, we're going to contain m to the 4th and n cubed. And they are multiplied together. There's no addition. And the denominator has that lonely p. Ta-da! All right, we got one with numbers up next. We're going from elegant form into inelegant form. So we have 3 ln of 2, by the way, understood base is e, minus 2 ln's of 5, natural logs. So same as before, put those exponents up, and you're going to have the natural log of 2 cubed minus the natural log of 5 squared. Now, by the way, this is math you can do. The natural log of 2 cubed is the natural log of 8. 5 squared is 25. You should do that. Now, do not do 8 minus 25. Don't be that kid. I've seen that kid every stinking blasted year. The kid's always wrong. He might be in my class twice. I don't know. Anyways, if it's positive, numerator, negative, denominator. So this is equivalent to the natural log of 8/25. Positive numerator, negative denominator. And are they the same thing? Well, of course they are. You don't believe me? Let's push buttons because you'll believe anything the calculator tells you. It's crazy how people will believe technology over a person when the technology was literally created by a person. Funny, huh? But there you go. Same thing. BRB. All right, condensing again, write it as a singular logarithm. So we got 5 log base 2 argument c minus 7 log base 2 argument n. Always move factors as exponents first. Now you're going to have a single log base 2 factor c to the, argument c to the 5th minus log base 2 argument n to the 7th. Now you can do your condensing. If it's positive numerator, if it's negative denominator, so c to the 5th and up high, n to the 7th down low. And we got another one of these with numbers. Big whoop. We got a natural log of 7 squared, which is a natural log of 49, because we know what 7 times 7 is, right? I hope we do. Plus a natural log of 2. Okay, so if it's positive, it goes in the numerator, and we attach them through multiplication. So this becomes a single natural log, base e, by the way, 49 times 2, contains 98. And of course, the e is understood, but I'd like to write it to remind you of what it is, because you have to know that ln has a little bit of e down there. Moving forward with our lives. Properties. pH is a logarithmic scale. The pH of a solution is a measure of its concentration of hydrogen ions. The concentration measured in moles per liter is written as H plus is given by the formula pH is log of 1 over H plus. What is the concentration of hydrogen ions in acid rainfall? So they gave us the pH. Well, go ahead and just throw that number right there. She's 4.5. I'm going to say she's a log. By the way, log has another subbase of 10 of 1 over H plus. Now, I don't know that you have to actually apply the properties of logarithms. You can if you want, but it seems silly to do it. I know what the author of your textbook wants you to do. They want you to write 4.5 equals log base 10 of 1 minus log base 10 of H plus. That's what they want you to do because they believe, and I know better, that you will recognize this as 0. They think that you will realize that you will read this as what power of 10 equals 1. And you'd be like, oh, that's a 0. Like they think you'll know that. You should know that. But you grew up in America where you get passed for being able to breathe. Anyways, that's a 0. Okay. Now, the next idea here would be go ahead and just divide out that negativity on the logarithm because we want to do a conversion into exponential form and we need it to be a log, not a negative log. So negative 4.5 equals log base 10 of H plus. Let's see, we got a base, we got an argument, we got an exponent. So our base is 10, we raise her to the negative 4.5, and that would be equal to the hydrogen ion concentration, 10 to the negative 4.5 power, which is a teeny tiny little number. It is. You don't believe me? Let's see. You need to remember that that's 1 over 10 raised to the 4.5 power. It's tiny. 5 zeros before that 3. Let's see. What is the concentration of hydrogen ions in orange juice? Let's do this one a little bit different. Orange juice is 3. So 3 equals a log, whose base is 10, of 1 over H plus. Now I'm going to do this one a little bit different because the way the author of the book would like you to do that is nonsensical. Well, whatever. It's something. You can go straight into exponential notation. 10 cubed is 1 over H plus. 10 cubed, last I checked, was 1,000. No? Yes? No? Anyways, we're going to put that over 1. H plus times 1,000 is 1. And then we're going to divide by 1,000. So H plus is 1 over 1,000, which is not that small, but it's 0.001, which is a lot bigger than the previous one. All right, what do we got here? Evaluate logarithmic expressions by changing the base. How can you use base 10 logarithms to evaluate base 2 logarithms? So to evaluate log base 2 argument 3 with a calculator, you got to express log base 2 argument 3 in terms of base 10 logarithms. This would become a log of 3 over a log of 2. So here's change of base. Let me make sure it's not in these notes somewhere else. Okay, it is. And then we go to a calculator and we push buttons because we don't have a log base 2 button. Log of 3 sitting pretty over log of 2 is that guy, 1.58496, so 1.850. Milbrath, why'd you include the 0? Because I go 4 decimal places. That's why. 3 ways of rewriting log base B argument A. She could be log of A over log of B. She could be the ln of A over the ln of B. And then there's the big one where you choose your own base. That's log base C of A over log base C of B. Bases stay down low. Bases are the bottom, right? All right. Estimate the value of each logarithm. Use a calculator. Now, I am a huge fan of the ln one. It's more elegant. So you will see me primarily do this. It's the ln of 7 over the ln of 2. What's high stays high. What's low stays low. But if you like logs for some reason, you be that kid. You shouldn't be that kid because, well, The good ones don't use it. Model success. The good ones use the ln, not the log. But what do I know? It's not like I've taught 1,500 odd kids. But they are equivalent. They're both roughly 2.80735. So 2.8074. Log base 5 of 3, well, she could be an ln of 5 over an ln of... Sorry, I did that one wrong. She's a natural log of 3, sitting pretty over natural log of 5. What's high stays high, what's low stays low. Natural log of 3, sitting pretty over the natural log of 5. Ta-da, 0.6826. All right, what is the solution of the equation 2 to the x equals 7? Express the solution as a logarithm and then evaluate. So yes, we could immediately go to y1, y2 if we wanted to, but they want us to express the solution as a logarithm and then evaluate. So all you got to do is identify your pieces. 2 is your base, this is your exponent, and this is your argument. And of course, you are expected to have memorized that log base b, argument a equal to e is equivalent to b to the e equal a. So my logarithm has a base of 2, her argument is 7, and she equals x. That is the correct answer. Now, if you want to know what it is as a decimal, you type it in like this: natural log of 7 over natural log of 2. That's your x value. What is the natural log of 7? Sitting pretty over the natural log of 2. Here's about 2.0. Oh, we've already done that one. 2.8074. All right. I'm not going to do that one, and I am done. I took 16 minutes on video. It's probably 30 minutes in class.